about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti, and let's read some code together, shall we? What we have on the menu today is two things. First, we want to explore the effect of... By the way, hi. If you are new here, what we do over here is we talk about building real-time audio effects. And specifically, we are looking at audio effects in Reaper, and we are doing a library. And the library has functions like this one to draw a waveform, because the main purpose of the library is for effects that are developed using the library. They should show what they're doing to the audio. That's the main point of the library. So, okay, coming back to the main course of today's menu. We will do two things. The first is we are going to explore the effect of changing Retina support on performance. That's just an idea that I had and I want to explore real quick. We are at 30 frames per second on this waveform drawing thing because when I was at 60 frames per second, Reaper was not able to keep up with the frame rate. It was dropping frames, so the animation was lagging. But then I thought, okay, if I have a choice of better frame rate or better resolution, I think I might prefer having a better frame rate. So if I disable support for Retina display, currently support for Retina display is enabled. And we have enabled that way back in the beginning because it's the obvious thing, right? If you can have more pixels, you want to have more pixels. So we enabled that way back in the beginning of the library development, but now I am questioning that decision. Should we instead opt for non-Retina and instead perhaps we could have a higher frame rate? That would be advantageous. I would like that. Perhaps we could bump this up to 60 frames per second. Who knows? So we are going to, I guess, focus on this view where things scroll by, because that's slightly more difficult. We have to bleed parts of an image twice to make this happen. And so far the performance here has been good. So perhaps we have to change this effect to make it not as good so that we can see if disabling Retina support will improve performance. Let's go to the source for the effect, which is this one, and I will enable 60 frames per second. How do you do that? I always forget. I always go to the docs, and then I look for 60, and here it is. This is how you specify a frame rate of 60 frames per second. In our previous experiments, we were able to determine that this was not able to keep up. So hopefully we'll be able to see if disabling Retina will help. And Bo is here. Hello, it's great to see you. I hope you find today's session entertaining because we are exploring a tangent that an idea that I had, but the main course is going to be reading a lot of code, as we are about to see. Oh, and you have a juice question. What does the asterisk do? Like in auto asterisk. Okay, let's answer that. This is not a juice question exactly. It's more a C++ question, okay? Because the star has nothing to do with juice itself. But it just so happens that I do have juice here open. We might get to the source code for the audio thumbnail class, because the audio thumbnail class does something pretty similar to this. Oh, and by the way, we are able to decrease the frame rate here. Or we are able to stress the system here, because if we ask 60 frames a second, Reaper cannot keep up. As we can see here, it's never giving us 60 frames. And yes, the animation is glitching. So great, we were able to do that. In any case, the audio thumbnail class here in Juice does something very similar to what we want. So we may get to that code. Oh, you're saying that you Googled and nothing C++ specific showed up. That's interesting because Google is not really able to search for punctuation all that well. Perhaps if you put it in quotes, but if you search for something like auto star, I think it's probably going to ignore this star because it isn't aware of programming language syntax. Maybe this has changed, but... And there are characters like minus and plus that are common in programming language syntax, but Google assigns different meanings to these things. Like if you say minus something is because you don't want something to appear in the search results. Anyway, we may get to the source code for the audio thumbnail class in Juice, which implements something similar to what we want. But I will just, because I have this open, I will explain the auto asterisk using the Juice source code. I'll try to find an instance of the auto star thing. And it appears that in the audio thumbnail that doesn't occur. Oh, it does occur. Okay, so in the audio thumbnail.cpp class or audio thumbnail.cpp file, there is an instance of auto star. So we'll be able to talk about that with an example. All that showed up was hiding texts with asterisks, like hiding a password, I suppose. Interesting. Anyway, so let's start with the auto and then we'll talk about the asterisk. So back in the day, I don't know exactly when this was introduced, but back in the day, when you were defining a variable in C++, you would need to do something like this, int, and then let's say that my variable is called hello. And this has been around forever, okay? This has been around since the early days of C. Perhaps even earlier than that, I don't know. But in some cases, you're not only declaring a variable, you're also initializing a variable. And now this time I'm saying that I want a variable called hello, and to begin with, its value is 100. Now, it can be kind of silly for you to do this because you have a value here. So of course the variable needs to be an integer because I have an integer here. If I had like, let's say, hello, then of course this is not an integer. This is a string. I am hand waving over the actual types here, but numbers can be complicated, strings can be complicated. But the point here is, if you have a value, you're declaring a variable, but you're immediately assigning a value to it, you could not say what the type is. And the compiler could say, okay, whatever the type of the value is, that's the type of the variable. This is a handy shortcut. It makes code easier to write, perhaps even easier to read. And it may not be a huge win when you have a number, but in many cases you don't have a number. You have something more complicated, like a class. And then you would typically write code that reads like this. If you have a class to represent a person, say that that class has things like age and name and a favorite color and that sort of thing. So you have a class representing a person, and you want to have a variable with that person, called person. And then you need to instantiate a person. So this line doesn't read that great, does it? The capital P person is the name of the class, so that's a type. It's similar to int. lowercase p is the name of the variable, just like hello. And just like 100 is a value, which is a number, new person is a value, which is an object of the type person. But then this line reads as person equals new person, which is ridiculous. So in relatively recent versions of C++, as well as in many other languages that follow this pattern, like Java for instance, they introduced the notion of what C++ calls auto. And in Java you would write like this in case you're curious. But anyway, it's just saying, take the type of the value and let that be the type of the variable. And then you can write a line that reads slightly better. In this case, I think it reads pretty well. And in this case, you are saying person twice, but note that one is capital P, so that's the class, and one is lowercase p, that's your variable. So that's what auto is. It's just a way of taking a shortcut and saying, if you are declaring a variable as well as initializing it right away, I don't want to say what the type is. Compiler, please take the type of the right-hand side and assign that to the variable. So that's what auto is. Now, let's explain what the star is. Well, we sort of talked about this last time. I think it was on Monday or Tuesday, I forget. But we talked about how the star can actually mean different things in different contexts, but in the context of a type, it represents a pointer. So let's say that we have this person situation, okay? And remember how we talked about when you call a function, let's say that there is a function called say hello to, and then you pass as an argument the person. Well, the way that this call to this function is going to work is there is going to be a copy of that object that represents the person, and that copy is sent to the function. That's just how function calling works in C and C++. It's by copy. Until you tell it otherwise, its function calls occur by copy. You copy the argument. So you would copy the person, so you would copy their age and name and their favorite color and whatever else you're storing in person. Okay, so that isn't great. And there are other things that you would like to be able to do, perhaps. Maybe say hello to wants to modify the person, so having a copy will do no good, because you will not be able to see the modification from the outside. So if you expect person dot, I don't know, favorite color to be different because say hello to changes their favorite color. I don't know, this example is bogus, but anyway, if you would like the change to be visible from the outside, having a change on the copy will not work. So you actually want to pass a pointer to the person. And last time we talked, I said that if you want to have a pointer to something, you do it like this. Okay, so this is saying, please get me the pointer of this value. And this is how you do, this is how you get the pointer from a value. But suppose that you don't want to do this right away in the function call. Then let's say that we want to have a variable. We don't know its type yet, but we want to have a person pointer. Okay, and then we are going to pass the person pointer there. Why would you want that? Well, perhaps you're using this pointer in multiple places, or perhaps you're doing some other trickery with the pointer. I don't know. You just want the pointer as a value that you can hold on to and do stuff with. You just want to extract that ampersand person that was here into a variable. Okay, so what's the type of that? Well, it is a person pointer. So this is how you get the address of, and this is when you're talking about a value. So you use the ampersand with a value. And when we are talking about the type, you say asterisk to mean pointer. It can be slightly confusing. One is an ampersand, the other is an asterisk, and one goes in the beginning and the other goes at the end. I am 90% confident that I'm getting the syntax right here, but in any case, this means I want a pointer to a person, which is not exactly the same as a person. A person is a chunk of memory with some data. A pointer is the address of that place in memory. Okay, so this is how you say that you want a pointer to a person. But oh, hang on. We have that situation again where we say person, 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 person on the line. So we can't just say auto here. And the compiler is going to say, okay, what is an address of here on the right-hand side? I'm getting an address of something. What is it? Well, it's a person. Okay, so this is going to be person pointer is going to be a pointer to a person. And specifically, we have to put the asterisk here to say I'm adding a pointer to that thing. I'm not getting the thing itself. Okay, so that's what's going on with the auto star. Now let's look at the example here from the Juice library. Well, there is this source that is the audio. Well, it's not really the audio. It's more like, you can think of the source here in this context as a wave file. And a wave file is something that you can get the audio from. It's like the little box containing the audio. So you're saying source. And then you have the little arrow operator that we talked about last time. And then there is this create input stream. We don't have to worry about what that does, but it's just getting the audio from the box. And then that audio is going to be represented as a pointer. Why? Well, because it's in many cases you will want to modify this audio. Or perhaps in this case, I guess you could just want to read that. But you could also write to a WAV file under other circumstances. So what is returned by this is a pointer. We don't want to have to say what's the type of this. It's probably some type like vector or buffer or audio stream. It doesn't matter. What we want is just a pointer to dash, and we don't want to have to be explicit here and say something like buffer or vector or audio input stream or whatever. We want the compiler to say, okay, let's look at the return type of this right-hand side, and audio file stream is a pointer, hence the asterisk. It's a pointer to whatever is returned. That's the best explanation I can give for what auto star is. It's a combination of two things. It's a combination of star, meaning pointer to, and auto, meaning please compiler, you know what I mean. Don't make me write it. Don't make me write the type, because you know what the type is. It's the type of this thing. I just initialized it. Figure it out. So that's what auto star is. I hope that helps. Let me know if something isn't clear. Oh yeah, and I guess your question was, what is the asterisk? Well, the asterisk is pointer to. An auto asterisk, it's pointer to something that can be inferred by the compiler. And incidentally, here you would not be able to use auto, okay? Because here you're not initializing a variable, you're just declaring it. So just by looking at this, the C++ compiler is going to say, okay, but what's the type? I don't know. So auto cannot be used everywhere. There are some places where you have to be explicit about the type. And there are some places where you could, in theory, have auto, but you prefer not to have it because you want to communicate with the reader what the type is. So in some cases, you could have auto, but decide not to use auto because you think that in that particular place, the person reading the code needs to see what the type is. Okay, that's all I'm going to say about the star or the asterisk in auto. I hope that helps. Right, so let's get back to the issue at hand here, where we increased the frame rate to 60 frames per second. Reaper is never giving us 60 frames a second, especially when we are doing other things like moving the window around, then the frame rate drops to a solid 40. And now let's see if I disabled Retina. What happens if we get a better frame rate, and also how things will look. Now, there is something interesting going on here. This JSFX X Retina is a weird little variable. It's a special variable in JSFX. If you set that variable in the init section, this part, if you set that variable in the init section, then the variable will be available everywhere else, and it will be either 1 or 2, depending on whether Retina is disabled or enabled, respectively. And there are many places in the rest of the code where I use the variable to mean either 0 or to mean, sorry, to mean either 1 or 2. So I don't know what's going to happen with the rest of the code. It may be the case that the rest of the code is just going to see 0 here, and then things will blow up. I don't know. I don't know what will happen. Let's see. Yeah, it seems like this is working fine in the sense that nothing blew up, and I can tell, I don't know if you on the stream can tell, but I can tell that Retina is disabled because things look more blurred now. But now what's interesting is that my FPS thing is not showing up anymore. I think it has to do with what I just explained. The variable doesn't exist, so its value is 0, and we are multiplying by 0 in a bunch of places. So what I'm going to do is find our occurrences of X Retina and replace with 1. And perhaps we'll have to do that here as well. No, it's not used there. Okay, and now we get the frames per second meter again. And it does seem that we can get a better frame rate if we disable Retina support. What happens when we move to the scrolling situation here? Okay, it seems to hold, but not always. And it is a bit jumpy. Let's do the stress test of moving a window around. And we get down to 40. Yeah, so it's not a huge difference, I would say. I think that the performance is about the same. Well, we are doing half of the work because we're drawing half of the pixels. But still, it doesn't seem to affect too much. It seems like having a higher frame rate is something that Reaper struggles with, regardless of what you do. Or maybe my code is doing something silly and then Reaper cannot keep up. But I think it does make sense because all the rendering is happening on the CPU, and there are things that are higher priority, like processing the audio, encoding my stream, all of that. So Reaper decides probably to lower the priority of drawing the JSFX block. It is what it is. So we explored the idea, and the conclusion seems to be things get better, but still not 60 frames per second. It's not the same as when I disable 60 frames per second, getting back to 30, which is the default. Then we get a solid 30 that is stable. This number doesn't fluctuate. Well, not too much anyway. If I move things around, we got down to 29. I saw 29, but mostly we are on 30 pretty solidly. So I guess we will leave Retina on. It's good for fonts. It's good for the crispness, of the waveform, but we'll leave at stuff at 30 frames per second. And also, if you ever embed that on the MCP, then we get 60 frames per second just by virtue of this being on the main window now. But because it's much smaller, it seems to hold a bit better. It's still not perfect. You can see this number going down. It's mostly okay. So that's the result of the experiment. Things get better, but not 60 frames per second. Okay, so now let's go to the main event. All of this was just a sidetrack. The main event and the title of this stream is to do a dramatic reading of some JSFX, and perhaps even some C++, who knows. So what I did is, I collected a bunch of JSFX that do some form of scrolling displays. The ones on the top even do waveform displays, which is exactly what we are looking for. And then some of them are more like esoteric, like this is scrolling a spectrogram. But all of them scroll something on the screen. And before I know that I'm obsessing with the smoothness of the scrolling and everything, but the best way to learn is to see what other people were doing, and we worked in isolation for a good while now. We tried many ideas and experiments, and some of them panned out, some of them didn't. So now I have two questions that I want to answer. How do people communicate information between the audio and the UI threads? The way that we did this, well, we did it in several ways, but right now the way that we are doing it is we have a relatively small buffer where the audio thread writes to and the UI thread reads from. And it's a circular buffer, and it's a relatively small one, and we are doing most of the computation of what should be displayed on the audio thread. So I guess that's another question. Which thread does most of the work? So we tried both ways. We tried, and most of the work in this context is reading all the audio, so 48,000 samples a second. And sometimes, depending on your resolution, that 48,000 samples is going to become like 2 pixels or 5 pixels or 10 pixels on the screen. And even if it's 100 pixels, it depends on how much you want to show of the waveform, but even if it's like 100 pixels per second, 100 is still much less than 48,000. So you do have to do this scaling of the high resolution information of the waveform or of the audio down to the relatively lower resolution of the waveform display. So which thread is doing that? We did that in the UI thread, we did that in the audio thread. It seems to me that the audio thread is better at doing that. It runs more consistently, and when the UI thread has a chance to run, reading over all the audio is too much work, and then frames are dropped. And the third question that I want to answer is, how do they scroll stuff across the screen? We explored a couple different ways of doing that. Right now, what we are doing is we are drawing to an off-screen image, and we are just drawing from left to right like a circular buffer. And then we blit that image, so we render that image onto the user interface in 2 chunks, and we make it so that the separation, or I guess the edges, match up perfectly, and then you don't see the way that they connect. But that's how we are doing it. And it's a bit complicated. It involves splitting twice. The code for it's not difficult, but it isn't easy either. And I wonder, how are people doing that? All right, so let's start the dramatic reading, and we will go over the source for all or some, probably just a couple of these plugins, and try to answer these questions. And it will be entertaining, I think, because it's not something that I did before. It's something that we have done with the authors of some effects. We bring them over and we talk about some of the stuff that they did, but it's always different from someone. It's always different to have someone else look at the code and try to make sense of it. So I will give you some insight into the process that I use to learn most of the stuff that I know and how I go about figuring things out. That's the plan anyway. First of all, let's see all these plugins that I have on my list. What I did is just I went over my list of JSFX and I found stuff that I thought was going to have this view, and some of them I even knew off the top of my head. So to begin with, this one is available in Repack. It is meant to be embedded on the MCP, so let's do that. And then it looks like this, and it is very similar to what we are developing. We are developing something that is meant to be embedded in the MCP, and it shows the waveform just like that. And yeah, there is something interesting already going on here. Pay attention to the top. You will be able to see it glitching at points. Oh, on this one, it was glitching as I was speaking. You see that? See how it glitches a little? We saw that happening. We had that bug. This bug, as far as I can tell, has to do with you writing stuff on the audio thread and reading stuff from the user interface thread. And then there is this race condition, this concurrency. The audio thread is writing while the UI thread is reading. So we have a pretty good indication of how they are doing this, how this plugin answers these questions. We have a good guess of how it works because we saw this bug before. We ran into this bug. And the way that we solved this bug was for the audio thread to write and the UI thread to make a copy of. It makes a copy of what it reads. And then from there on out, it reads from the copy. So the race condition is solved that way. So we'll look at the source for this guy. Let's see the next one. I think it's by the same author. I'm not really sure. It looks like this. And it does almost exactly what we want. And if we slow down the speed, it is almost exactly what we have, or what we want to have. So there is something cool happening here with the color. You can set the color, which is perhaps something that we want to have in our version as well. I am not super keen to having that because, well, we do have a design system, so this would be actually kind of nice to have. But I think that having customization and themes, I don't like themes. I just don't like them. I think it's nice for people to design their plugins and then give their plugins designed to people, not give plugins for people to design or give the pieces and then have people say, okay, it doesn't look all that well, but it's customizable, so go ahead and do it yourself. I know that people love customization and it's part of the Reaper ethos, but I don't know. Maybe we'll have something like this. Right, so this is, I guess this makes things better if I display on this scale. And there is something interesting about the way that the colors change as I am changing them here. You can see that it doesn't change the color of the whole waveform, it changes the colors for the parts of the waveform that are coming in. So I guess if you modulated this parameter, you would have a rainbow waveforms. And the reason why I think this is interesting for our investigation is that I believe this indicates that they are doing some off-screen drawing just like we are. Because when you are doing off-screen drawing, once you drew, you drew. If you drew in green, it's going to be green. If you want to change the color, you can for the next stuff that you are drawing. But what sorry, what you already drew is there. So I believe that the answer is that this guy is doing that little writing and reading situation, and this guy is doing the copying and the off-screen drawing, I think. Oh, and something interesting to answer is also what they do when they go off-screen and then back. So right now, this is drawing. Well, I guess it's still drawing, but now it isn't. So we have in our version some provisions to detect that we are not drawing, and then we erase stuff when we get back. So let's see what this is doing. Interesting, I don't see the clicks. Now I got one. Interesting, so I guess this is another symptom here. This plugin is missing the clicks. So it means that it is not looking at all the samples, it's just looking at a subset of the samples. I think we ran into this issue before as well. So it's looking at the subset of the samples and it's missing my clicks from time to time. Okay, so the test will be, I will click, I will close, and then I will reopen. And if the click is still there, it's not erasing stuff when it closes. It seems to be erasing. None of my clicks are getting there. Interesting. Let's try this again. Ooh, the weirdest thing happened. This signal is mono, but the right channel was different from the left one. Yeah, I don't think I love the implementation that they have on this one. It seems to be doing a bunch of glitchy things that we are trying to avoid. But it still be interesting to look at the source for this one. And this one seems to be doing, I guess, something that we also did, which is to yeah, I think that this one is doing the copying. As I mentioned, it's copying into an image off screen. So it means that when I go out and back in, the click will be there. Let's check. Yep, that's what this one is doing. It's also what ReLimit did. Yeah, I don't think I love this one. Now, this one is by Cocos, so I think it should be a good reference of what JSFX should be like. But the problem with this one, and the reason why it's not at the top of the list, is that it doesn't do exactly what we are looking for. If you zoom all the way out like this, it does show the waveform, and that's great. But it is an oscilloscope, which means that you are able to zoom all the way in and look at samples individually, like this. So you're able to see each sample. And that means that they have to do some things, like they do have to store all the samples, because you may want to zoom in to individual samples. So we can already tell for a fact that this one is doing the work on the UI thread, because it has to. Or perhaps not. Perhaps they have some optimization, and it would be interesting to see. But yeah, it's an oscilloscope, so it doesn't work exactly the same as what we want. There is something else that I'm interested in knowing, which is what happens when I go out and back in. I think it does the same thing as ReLimit, the same thing as this guy, which is to just pretend that the time in between didn't pass. But at least that one showed the click, very nice and sharp, unlike these other two. And the click is no longer there, so it seems like it's just storing all the samples. Well, interesting. It's not like ReLimit. Then there is this guy. This guy is a compressor, and in many ways it is very much like what I do want to build. it looks good. But okay, so what are we interested in knowing? I guess we can see that it does glitch a little bit when moving across, and I guess all of them do, so that's inevitable. It's probably a limitation of drawing in JSFX. Let's do the click test to see what it does, to see if it is pretending that the time didn't pass. Oh, see, the click appeared here. So that means that this guy is collecting samples even when it's on the background. Okay. Yeah, and I guess my click was moving across. I don't know, I'll have to do the test again. Yeah, I guess this one is similar to this one in spirit. It's always collecting samples. Because it is not resetting. When I go back and I'm in the middle of speaking, it's not resetting. So it's collecting samples even in the background. And the trade-off here is, that's actually the ideal behavior. If you have something going on and you are like, okay, I want to see the waveform for that, you go and the waveform is there for you. Great. But the bad part is that you are storing samples, so you're doing work even when that is not going to be used. So right now I'm not showing the tight compressor and it's still collecting samples to be able to draw this waveform as soon as I move there. It is, in many cases, is wasting resources. Unless you're looking at it, it's wasting resources. Smooth Limiter by Geraint Love. So this one actually scrolls the smoothest for me. I don't like the aliasing on the waveform, but it scrolls very smoothly. I guess it is because it's moving across relatively fast and the window is relatively small, but still, it does look good. It's not my favorite because of all the aliasing, but it does look good. I would probably try to draw things a little bit thicker so that they don't have so much aliasing. And of course, if you go to lower frequencies, then it will alias again. But I guess what we are doing is trying to find a good compromise in the middle. Moves across so fast. Yeah, okay, it's always storing stuff. And if I am speaking in and I go there, it's going to be storing stuff. So it's all these three seem to be doing the same thing. And then there is this one, which is not really a waveform display, but it does scroll across the screen and everything. So I think it would be nice to look at this one. Oh, see, this one behaves differently. My click was about the middle of the screen and it will continue to be there. So yeah, this one pretends the time didn't pass. It does, I guess, put a line there, but it pretends the time didn't pass. And perhaps pretending the time didn't pass, but putting some sort of separator is kind of nice. Yeah, I guess I will take note of this. It would be nice to pretend that time didn't pass, but put a separator. Or it could be nice, I don't know. When I say that pretend that time didn't pass, is just detect that we have been off screen and we're back, but don't erase the whole screen. Just put some sort of marker so that you don't lose what was there before. Okay, there is this. It's similar to the previous one. Perhaps it's even an adaptation of the previous one, because on the previous one there are settings for you to change the display like this. And now you could also, I guess, change the colors and everything. But then it starts to look like what shows up here. Perhaps this one is better because it's finding the harmonics and everything, and this one is not as much, but it also has to do with the size of the FFT for that. If I do it like this, then it starts to find these guys, and perhaps if you gauge things correctly, it will start to look like this one. But this one is also scrolling across. It is kind of smooth, so there is that. And then there is this one, which I think is just so fun. I love the way that this looks. and so many things moving around. And if you click here and drag, then you see all these particles moving, and it looks so great. Of course, it's mostly like contours and shapes, so things perform well enough. But what I'm mostly interested in is this background thing, which is a representation of the waveform. And it does scroll by very smoothly, so I like this one. All right, so those are the contenders. Let's see their source. Perhaps I will duplicate them because my preferred way of reading code is by interacting with it, changing it around, changing variables around, moving things around. So I don't want to lose this effect that I have installed. So I'll add an inline input viewer, right click, duplicate, and I will call it JSFX. I'll keep the name. All right, there we are. And it's still working, but not quite exactly the same, which is odd. I am aware that if I move some things around and they're importing stuff, things may break, but I was not expecting to see this kind of difference. Well, it is what it is. So now we have this. Let's check it out. And in particular, we'll try to focus on what we don't care about. So we'll try to focus on these questions and try not to pay attention to everything else, because there will be a lot of things extra. Maybe not in this plugin because it's just a waveform display, but even that is doing waveforms, but it can also do MIDI. So we'll have to get rid of stuff to make sense of this. Stop messing. You don't tell me what to do. Okay, so they have some buffers going on. Interestingly, the sample buffers come later and the MIDI buffers come first, so maybe this indicates that MIDI was implemented first. There is a way to zoom on time. Oh, okay, and there is also a mono version, but I don't know how to zoom. Yeah, I tried all the modifiers, nothing happened. And are there sliders for this one? I don't think so. Okay. So let's go to the sample block. Don't do this if in MIDI mode to improve performance. So don't do if in MIDI mode. But I am not in MIDI mode. I'm interested in the audio mode. So I guess this is the code that I'm interested in. Oh, I think I understand. So on the sample block, it's doing the audio processing, but then you can see that it's over. And on the block section, it's processing the MIDI. Okay, that makes sense. You don't want to process MIDI on every sample, or unless you're doing a trick that Dale showed us when he was over, but MIDI you probably want to process in the block section, and audio you can process on the sample section. Okay, so it is doing a bit of work here to prevent clipping. So this is probably because if this audio gets too loud, maybe let's say that the left channel gets too loud, but the right channel is not. So maybe the left channel will cross over to the right channel unless you clip stuff. And we are doing that, we are clipping, but our clipping is sort of a bit, it's kind of a trick. The way that we are clipping is we are drawing to an off-screen image. So if we draw beyond the boundaries of the off-screen image, that will be clipped when we bleach. So we don't have to worry about this. Because they do have to worry about it, they have to explicitly clip samples. It indicates once more that they are not doing off-screen drawing. And then they have some stuff to zoom. And then they have some stuff to move samples one buffer space back for each channel. So it seems like they're doing the circular buffer in a different way. The way that we do a circular buffer is we have a chunk of memory and we have a pointer that we move and then we ramp back. So that's how our circular buffer works. We have just this pointer that moves forward, ramps back, and the pointer is like this, the base address of the circular buffer. But another way of doing a circular buffer is every time that you want to advance the circular buffer by one element, you copy all the elements and you shift them forward. Or you shift them backward, however you want to think about it, but you're just shifting all the elements. Sorry, you're shifting all the elements. So that's another way of doing a circular buffer. It strikes me as an expensive way of doing the circular buffer. But who knows, maybe it is fast. See, that's exactly what they're doing here. They're moving samples around. How is the performance of this? It's okay. I'm surprised. Store the samples within the buffer and offset them at clipping to store the clipped state. That doesn't ring a bell. I don't know what that does. Zoom time reached. Okay, so this is just doing collection of samples on the sample block. It is not doing the reduction from samples down to pixels. This is just receiving MIDI. Then, oh, that line is interesting. It's storing the version, I think, but it's storing that without a variable. I didn't know you could do that with a single line. Oh, and the ratio seems to be 1.5. I didn't know that. This aspect ratio of this little embedded thing here is 1.5, they seem to think. Let's see if we can reproduce that. Yep, seems right. Yep. It is 75 by 50, roughly. So that's a ratio of 1.5. All right, store the height to optimize the sample buffer. I wonder why that is relevant. Clear color, okay. We have a function that is very similar to this, except that it's aware of our design system. Then draw sample. Draw all the samples that are non-zero, show clipping. Oh, that's kind of an interesting thing that we sort of saw when I was clicking. We saw that if we clip, the waveform becomes red. So that's what this part is doing. I guess I can show you this. Let's just put a gain plugin. Yeah, not this one because it's broken right now. Let's put another gain plugin. This one should do. And then you can see that if I speak anything that is too loud, it turns red. Great. And we are back. I removed that, but you can see the red above. Interesting. Okay, draw sample. We have some indices, probably into the buffer, some X and Y position and the size. Okay. Draw only samples non-zero, show clipping. So to show clipping, you just change the color. And then draw a line. That's similar to what we are doing. We are doing it with rectangles. We are doing it with a rectangle of width 1, but perhaps drawing a line would be faster. We need to investigate. And when I say rectangle of width 1, I can show you what I mean. To draw one, I guess what I call a slice, I am drawing a rectangle of width 1. And here the same story. Perhaps doing a line would be wiser. It may even be faster. Okay, draw the waveforms if in audio mode. That's what we are interested in. Then we have this. Oh, this is very short. So we set a color, we draw a string. Huh, interesting. They are capitalizing the S, and that works because JSFX is case insensitive. Then loop over all the... Oh, interesting. Loop over all the pixels on the screen. And if we are drawing in mono, or if we are not drawing mono, if we're drawing stereo, then draw this. Yeah, let's look into that. I think I now understand why it was missing my clicks. It's not looking at all the samples in an interval. It's just discarding a bunch of samples and getting a representative sample from the middle. It may work well with music, I don't know. It may even work well enough with my voice. It's up to you to decide if you like this, but I don't think it's great because you're throwing away a lot of information and you're specifically throwing away the peaks. That's a bad idea, I think. So let's see what this I thing is doing, because that's the index. And the I is just incrementing by 1. But hang on, it's used in interesting ways. Oh no, okay, so I can be thought of as the row. And then the index here hang on, what's happening here? Because this buffer is supposed to be... This buffer is collecting all the samples as they come in. Oh. Is it collecting all the samples? I don't think so. This zoom time is a circular counter. That's what the time zone is. I was not understanding what the time zone was. So what the time zone does is it's a circular counter and we only collect samples when the time zone is equal to 0. So we are not collecting all the samples. We are collecting just some of them and we are discarding most of them. Because if the time zone is greater than 0, we skip over this and we don't store anything. So the processing of taking audio and downscaling it to pixels, that processing happens here. So it's happening on the audio thread. Let's perhaps take note of our discoveries. How do they communicate? With a short circular buffer. And the circular buffer is moved by copying all elements. Interesting. Which thread does most of the work? The audio thread. And how do they scroll the pane across the screen? They don't do off-screen drawing. And now this makes a lot more sense. This I is the index onto the circular buffer as well as the index on the screen, because the audio thread is already kind of computing what should be shown on the screen. And perhaps to make the thing show up all the peaks, we would not have this time zone situation, or I guess we would have a time zone situation because we do have a circular counter just like this, very similar to this. But instead, we would always be collecting stuff and taking the maximum and the minimum and whatnot. Yeah. Okay, and this is just about MIDI, so we can ignore that. And then very simple treatment here of the user interface. The only thing that happens on this user interface is when you click, you go into mono. So let's read this code because we haven't really touched on mouse interaction at all so far in our series of streams. So we are checking the mouse capabilities, I think. And then the GUI clicked is this. Yeah, it seems to be a JSFX thing. And then it's flipping the view mono variable and setting the GUI clicked to 1. Oh, okay, so GUI clicked is not a JSFX thing. Yeah, I thought that name one didn't really ring a bell. So mouse cap is something that comes with JSFX. I think it means which button was clicked. And I guess they are doing this check of GUI clicked just because you don't want to go into this as well as into that at once. And probably this means left click and this means right click. So if I left click, I am changing the mono situation. If I right click, I am changing the MIDI situation. Okay, I guess we answered all the questions for this guy. Let's perhaps take a look at the wave scope now. All right, let's get in there. Simple volume adjustment between -48 and +48 dBFS for non-destructive edits and gain staging between plugins. This is a copy-paste mistake, because of course this was not a volume adjustment. Having no meters is okay, I guess it makes sense. And then we have a bunch of sliders here. Things related to the buffer that will hold the samples, which the GFX part will use to draw the waveform. Okay, so this is being explicit. We have buffers to communicate between the threads, audio and user interface. Things related to the display, drawing colors, conversion from dB to gain. Oh, clever, multiplying by 0.05 instead of dividing by 20. Constants required for gain to dB. That's a lot of handstanding. Does it make things faster? I really wonder. We do something similar when we are converting from gain to dB. We add a very small value instead of take the maximum. Hang on. we do it here, but we don't do it there. We do the same thing in two different ways. Okay, that's probably because I was smart and I added this line and I didn't change this one. It's still doing a conditional. A conditional is always lower, I think. I think that doing a conditional is always lower, and adding an infinitesimal value, a very small value, is what I learned from reading the code from the SMS tools by the University of Pompeii. I don't remember. Anyway, what I want is to do this, and then I can remove the conditional. Now these two look more alike. But this test will be wrong. So let's run the tests real quick. And it should fail, and it does. And then we'll see what value is actually produced, and we'll paste as our expectation. Minus 120. And now the tests are passing. Power to dB, passing. Great. Coming back. Clamp, we have that. Or do we? We had at some point. It's just clipping. And again, they're doing the clipping on the samples, or at least they have a function to do that. So probably they're doing the clipping on the samples. So probably they are not drawing off screen. Okay. Oh, interesting. This is kind of cute. Then add to buffer. This will shift the entire buffer of samples left by one position, losing the first sample of the channel in the process. After shifting, the new samples are inserted at the buffer's back. It's essentially a glorified delay line. Again, they are doing this, at least they are not doing it with a loop, they're doing it with memcopy. So that's probably faster. Now I wonder if I should be doing a circular buffer with copying. I'll take note. Circular buffer by memcopy. And there is a restriction when you're using memcopy. You have to make sure that your buffers don't go over a certain boundary, which can be annoying, but we do have a memory allocator that can align. So that's not an issue, as long as your buffer is not too big. If the display is scaled to signed sample values and both left plus right stereo channels should be drawn. Okay, so they're clipping the samples on the way in. And they say that they're collecting samples, but really they're not. They're more like collecting the position where things should be drawn. Because they are already doing this bit. And we do something similar when we are drawing. I'll not go to the code there, but we are doing something similar. In any other routing scaling scenario, insert the latest absolute samples at the end of the buffer, clamping the samples to restrict waves to lanes. Haha. I like that this is well documented. This sets the drawing color for the display. Interesting. So there is this, I guess, principled way of converting the slider into colors. All right. And this is, if display speed has changed, then you do interesting. Then you do a bunch of, I guess you're resetting the buffers, but why do it that way? What happens when I change the speed? Well, first of all, this isn't drawing because it's frozen. But what happens when I change this? Oh, I know what's happening. Remember how I said that it was kind of weird that my input viewer in the beginning and the end didn't look the same, and then now the wave scope is not looking the same? We have a freaking beat crusher in the middle. So that's what's up. How about we turn off everything except for what we're looking at? This should help. Now this should look like the one on the top. We had a beat crusher in the middle. And this looks better. It looks smoother. So what happens when you change the speed? Interesting. I don't know. Block. Triggers a display freeze when project is stopped, or we enter into that mode responsive enough if this is switched in the block section. So saving some computation by not doing this on the sample section. Okay. Now, only push new samples into the buffer if the display is not currently frozen. So they don't have any notion of freezing when you are not displaying, but they have a notion of freezing, which is interesting. Collect the samples, then do some routing situation depending on what you are displaying. This is odd. This should be done with max, I think. Or could be done. And I think it would be faster than doing with a conditional, but whatever. Good enough. Okay, so they're pushing to the buffers. Now the question is this doing the conversion from 48,000 samples a second into pixels? Let's see. Let's try to answer that question. We are collecting samples. We are well, I guess the answer will be in add to buffer. And the answer is no, we are not doing that in the audio thread. So on this one, the UI thread is doing the, I'm calling this the decimation, the conversion from audio 48,000 times a second into pixels, about, let's say 1,000 pixels. That's happening on the UI thread. It must be, because the buffer is storing all the samples. All right. If we are not frozen, then... Oh, okay, so they are doing off-screen drawing. Cool. Setting the image dimensions. Oh, they're resetting the image dimensions to the screen size. I was avoiding that. I wanted the off-screen drawing to be a fixed size. How does this behave when I resize? Yeah, weirdly. Okay, I thought as much. You see some weird stuff happening on the right, and it is resetting essentially. Because the documentation says that if you have a bigger number here, as I do this, the number will become bigger. Everything else will be junk. Okay, copy the current main drawing context to secondary with an offset and paste it into the off-screen context at position 0. Doing this is the same as shifting an array. That is, it will drop an amount of pixels from the left side of the UI, leaving that same amount of empty pixels on the right to draw. Okay, I see. So what they are doing is they take what's on the screen, that's, I guess, -1. Yeah, frame buffer -1 is what you see on the screen. So they're taking what you see on the screen and pasting it on the temporary off-screen canvas, but they are offsetting it. essentially they are doing the circular buffer by copying. They are doing that with the image. So pretty much the same situation that we did, except that they are going to be computing the decimation on the UI thread. And this will amount to 2 blitz as well. But it may be a simpler way of doing it. In our implementation, we do 2 blitz. We blitz the left-hand side and the right-hand side, but they are doing 2 blitz. They are doing the blitz from the main screen into the off screen, and then from the off screen, they will have to blitz back into the main screen. So 2 blitz anyway. I guess the advantage of doing it our way is that we only need one temporary off-screen image, and we can do multiple waveforms if we want, because here you're depending on bleeding whatever is on the screen. So if you wanted to have any kind of label here, you couldn't, because the label would be moving to the left as well. So I guess I prefer our way. Okay, position X and Y at first MC pixel and make everything from there on black. This paints the background for the display. Okay, so I was wondering how they did the erasing. We had to do a thing that is probably not super performant, which is this. This is how we erase the display. We multiply each pixel by a bunch of zeros. Or not that one. This one. We erase by multiplying by a bunch of zeros, and they are just drawing in black. That requires you to know what is your background color. So you could not draw this waveform transparently. Okay, we do something similar to that. We do something similar to this. Okay. So now this is going to traverse the circular buffer, similar to how we do it. Oh, but they have this notion of speed. Okay, and the speed is just how much the thing was offset to the left. Yeah, we don't do it like that. So far, our speed is fixed. And if you wanted to increase the speed, in our notion, you would just zoom into the temporary image, I guess. Okay, they are doing lines as well, and something interesting is happening. They are doing a line from the center to the top, and then probably another one from the center down. Bo is saying goodbye. Bye. It's great to have you here. And yeah, have a good one. I see you tomorrow. If you're up for that. Okay, some more routing situation, but nothing here is super interesting. Oh, I think what is interesting about all this is that it's not doing any kind of decimation. It's just drawing one line per sample, I think. It seems to be. What's this step? and they don't have any notion of contour. And here's the second glitch. From the off screen into the main screen. It really seems to me that they are not doing any kind of decimation, but it's hard for me to tell. They're calling it step, what we call slices, they're calling step. Step may be a better name. And what's the treatment of this step offset? And when do we update this? We update it here. And where do we change the step offset? If at all. We don't. And how do we get the sample? We just get this sample from step. So it seems to me that it's not doing any kind of decimation. It's just relying on drawing 48,000 times a second, I guess. Seems to be what this is doing, yeah. And it's not gonna lose any clicks. Yeah, perfect. All right. I think that this was a good session, a good place to stop. So we learned about some of these guys. Oh, interesting. When there is no audio coming through, this just, I guess, keeps repeating what was on the buffer. We do something smarter. We detect that the audio thread is no longer running. Now I wonder what other ones do when I stop the audio. So this one, when I stop the audio, it just stops on its tracks. This one, oh, it's the same as the other one. This then does the glitchy thing. This one is smart. It just stops like that. This one is probably going to do the same because it seems like they all work under the same assumption, all these three. And this one seems to be doing the same thing. That one seems to be, oh, it's this one is yeah, it's doing the same as the one that we just read. This is probably going to be, yeah, just continuing copying. Interesting. All right. Okay, I think that this is a good point for us to stop. We looked at the source for some of the plugins. Perhaps next time we'll look at the source of some other plugins. Perhaps not. I don't know. But I will see you again tomorrow. Maybe over at IDGQD, maybe over here. Keep an eye out. You will know. Thank you everyone who watched this. Thank you both for being active on the chat. I see you back here tomorrow, perhaps for some coding, perhaps for some audio production stuff over at IDGQD. Bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.